data step processing. So when coming to this data step processing, we are writing a program in the editor window, right? And we are executing that program. Executing as in we are submitting that program and we are getting an output. So what is the backend process it is doing in order to get that output? Okay. So we are creating the SAS datasets in using various methods, right? So we have like different methods, input methods, different input methods. We have to create the SAS dataset. Also, we have the output method to create the SAS dataset. Also, we are using set statement internally, like to create the SAS data, like to copy the data from one SAS dataset to the other SAS dataset. We are making use of the set statement. So we have like different methods to create the datasets, right? So what is the program flow, or what is the backend process that it is doing in order to get that output? Okay. So this concept is very important in certification point of view. Also, it is good to know to develop a efficient program like optimized programming. This data step, to know this data step processing concept is very important. Okay. Now coming to this data step, SAS data step processing, it will process the entire data step in two phases. Okay. One is compilation phase. One is compilation phase and the other one is execution phase. Okay. Compilation and execution phase. Now, coming to the first, we'll see what it will do in compilation phase and then we'll see what it will do in execution phase. Coming to the compilation phase, okay. During this, what it will do is, the first one, it will check for the syntax errors, okay. It will check for syntax errors, okay. Syntax errors as in, so every SAS statement should end with semicolon, right? So it will check for semicolon, okay. And also it will check for the misspelled keywords. Misspelled keywords as in, for suppose data is a keyword, right? So if the data is misspelled, okay. Then it will check for that misspelled keywords. Like suppose if you are misspelling the data lines or card statement, okay, or input statement, okay. So it will check for all that misspelled keywords. Next one. Next, also it will check for the invalid SAS names, okay. So we have to follow some rules and regulations for assigning the dataset names, or for assigning the library names, or for assigning the variable names. We have to follow some rules, right? Like it should be of 8 characters or 32 characters length. It should not contain any special characters. Should start with an underscore or a letter. Can contain numbers, but the starting letter character should not be a number. So we have all this some rules to follow, no, while creating the library names or dataset names or variable names. So it will, so if we are giving any invalid SAS names, it will check for all that invalid SAS names what we are giving. Okay. So in compilation phase, this is the first task to do for SAS. The next one is, it will create three things. One is input buffer. Okay. First one is input buffer. So this input buffer will be created. So this input buffer is nothing but it is a logical memory area. Okay. Logical memory area. So this is a temporary one. This is a temporary logical memory area. Okay. So this input buffer is created only when we are creating the SAS datasets, or if we are writing the program, only when using the input, infile and card statement. Okay. This input buffer is created only when we are creating the SAS datasets using input, infile and cards or data line statement. Okay. In the program, if we are using either input statement or infile statement or card statement, or all the three together, or any two in combination, okay, then it will create this logical memory area, input buffer, which we call as. Okay. The next one is, it will create program data vector. PDV. Okay, PDV is called as program data vector. Okay, this is also the logical memory area. Okay, it's not the temporary one. It's like logical memory area, permanent one. Okay, logical memory area. Okay. Next, I'll tell you the significance of this PDV and input buffer. Okay, what are these and what they actually do. The next one is it will create the descriptor portion of the SAS dataset. Okay, the descriptor portion of SAS dataset. What is the descriptor portion of a SAS dataset means? It will create all the information about the dataset that what we create. All the information as a descriptor information like the attributes, okay? Like the dataset attributes and the variable attributes. Coming to the dataset attributes, like attributes is nothing but like if we assign any label to that dataset, okay? That you call as the attribute, okay? What is the what is the dataset name? Dataset name is like attribute and also the label. Okay, that is like one of the attribute. Date and time, like when the dataset was created. Okay, how many number of observations are there? How many number of variables are there? This all comes under the dataset attributes. Okay. Similarly, if it comes to the variable attributes, okay. So what is the type of the variable? Whether it is a character variable or a numeric variable, okay. What is the length of the variable? Okay, what is the format? Format as in suppose if you take date or time, it will have like so many formats, right? Date 9 dot, dd, mm, 10 dot. So what format that variable is of? Okay, all this information will be we call as the attributes, data set attributes and variable attributes. Okay. So it will create the descriptor portion of the SAS dataset during the compilation phase. Okay. So in brief about the compilation phase, it will make the program ready for the execution in compilation phase. Okay. So initially what it is doing, it is checking for the syntax errors for all the semicolons. Are we ending each and every program statement with semicolon or not? Misspelled keywords, invalid SAS names, and for all it will check. And then it will create the input buffer and PDV, which are nothing but the logical memory areas. Okay. So when we are executing the program, it has to store some part of the data in its memory, right? In order to create the output. So it is creating, like it is making all its memory ready in order to store the data values like what we are going to execute. Okay. And descriptor portion is nothing but, so if you want to refer to any additional information about the data set, like when if it comes to the data set, like what is the label, does it have any label, what is the name of the data set, okay, or how many number of observations, how many number of variables, okay. Next, date and time when it is created, okay, when it is sorted, if we are sorting the data, when it is sorted, okay, are you changing the original data set? If you change the original data set, what it, like if you modify, changing is nothing but modifying, right? If you modify, when you have modified the data set, all that information will be contained. Coming to the variables like length, type, okay, format, all this additional information will be contained about the variables. Next, coming to the execution phase. In execution phase, it will process like how it will read the data. So you are assigning the variable names and also you are assigning the data values, right? So what value that we have to assign to each variable, okay? So all that execution will be taken care in this execution phase, like assigning the values to the variable, sending to the output, okay, to create the output data set. All that we call as the execution. Now, so we have three different methods to create the SAS datasets, right? What are the three different methods? One is input method and the other one is output method and the other one is using set statement. Okay. First we'll start with input method. Coming to this input method, what is the algorithm that it will follow is, we should have the source data, right? First, so it will look at the source data. So after the source data, what it will do is it will create the input buffer, like temporary memory area. Because in input method, we make use of this input and card statement and also the impulse statement, right? If you want to make use of any additional options, okay. So input buffer it will create. After input buffer, it will create PDV, program data vector, okay. After program data vector, it will send the data to the PDV is also the memory area, right? So from its memory area, it will send to create the output data set. Okay. This is about the input method. Now, let us take a sample program here. Data. We'll create a data set called test input. Will I input ID, name, and department. ID is numeric only, not a problem. So name is character, department is also character data type. Okay, and run the program. Sorry, cards, right? Cards. 101 is ID, name is A, department say IT. Okay, 102 name B, and department is HR department. Okay. Now let us run the program. So it will create the data set in work library. So it created the data set. Now let us check the log window. Okay. So if you check this log window, data test, input ID, name, department, cards, and run. Okay. So we are getting all the program statements, right? But we are not getting the information that is placed in the card statement. We are getting all the program statement, but not except the information that is present in card statement in log window. See, if you want that information also to be displayed in log window, okay, then you have to make use of the additional option called put statement. So if you want to display any information that is related to data values, then you have to make use of the put statement. Okay. Now make use of the put statement. After input statement, right here, put underscore all underscore. Okay. So that it will keep everything, whatever, so it will keep all this data lines also into the data lines as in this one. Okay. All this data values also it will keep in the log window. Display in the log window. See, ID equals to 101. That's what, right? ID equals to 101, name A, and department IT. See, 101 department IT, name A, and department ID. Along with the three variables that what we have given in the input statement, it is creating additionally two variables, right? What are the additional two variables? Underscore, error underscore, and underscore n underscore. Okay. Creating two new variables, underscore, error underscore, and underscore n underscore. These two variables we call as the automatic variables. Okay. So during the program execution, like during any SAS program execution, it will create these two automatic variables, underscore, error underscore, and underscore n underscore. Underscore, error underscore equals to, will have the values either 0 or 1. That's it. Okay. So here if underscore, error underscore equals to, just a moment. Okay. So if underscore, error underscore equals to 0, it means that there is nothing, no error in this program line. Okay. There is no error in this program line. So if underscore, error underscore equals to 1, then it means like there is some error in that program line. Okay. Underscore, wait, here name is a character, right? So let us suppose say we forget it, the dollar symbol. Okay. Now you check the log window. See here. So it is saying underscore, error underscore equals to 1, underscore, error underscore equals to 1, which means that there is some error in this program line. Here exactly, see. If you observe here, it is underlining the portion, right? Which means it has some error at that name variable, or it has some error at that name data value. Okay. Underscore, error underscore equals to 1. Okay. Now dollar. The next value is n equals to. Okay. This n equals to will be 1, 2, 3, 4. Okay. And keep so on. you'll have the n values like this, 1, 2, 3, 4, and so on like that. What are this 1, 2, 3, 4 means? So the number of iterations, okay? These are nothing but the number of iterations. So here using the input statement, we are assigning the data variable names, right? And in the card statement, we are assigning the data values. How SAS will assign that? To ID value, it has to assign 101. To name, it has to assign the value A. To department, it has to assign the value IT. Now take this one, okay? Take this flow, process flow. What is the source? The input. So data test, it will create a SAS data set. Next, input. What are the different variable names? These are the three different variable names, right? So after reading the input statement, it will read the variable names, okay? So all these variable names will be stored in the input buffer, okay? ID, name, and department. Next, when it goes to the card statement, it will understand, okay, these are the data values, okay? When it reads the first value, 101, okay? 101. Now, in the input buffer, okay, what is the first variable that it has stored? ID variable, right? So it will assign. So this is the first value and this is the first name. So it will assign that value to that particular name. Okay. Next, what is the next value to read in the same line? In the first line, what is the next value to read? A, right? And what is the next name that is present here? A. Okay. So it will assign this A to the variable name. Okay. The next value. What is in the same line? What is the next value to read? IT, right? So it will read the value IT. And what is the next name, like variable to assign? Department. So it will assign IT to department. So it completed reading the first line, correct? Now what it will do is, so unless it reads, why here it is creating the input buffer when we are using input statement or infile statement and card statement means it has to hold all these three variable names at its sum of its temporary memory, right? Until it assign the values. Suppose say first it is reading the value ID, okay, and it is reading name and department. So once it reads the first value, if it sends the same to the PDV and if the same is sent to the output data set, then what about the rest two values? So what it has to do, until it reads all the three values to all the three variables, it has to hold this all three variable names at some point, right? In some of its memory, it has to hold. So where it is holding means it is holding in the input buffer. All the three variable names it is holding in input buffer until it reads all the three values to its to all the three variables. Clear? Hello?
Yes, Pavani.
Clear. Yes. Okay. So the same after finishing reading this first line, same will be sent to the PDV. Okay. So from PDV, okay, from PDV it will be sent to the output data set. Okay. To create the first observation. So like that it will create the first observation. Okay. Like this it will create the first observation. Now, in order to read again the second line in the data line statement or in the card statement, again it has to read the input statement, okay? Because it has to say like in order to what it will assign this variable name, to what it will assign these values, okay? So because of that, what it will do is before it reads the second line in the card statement, it will again go to the input statement and it will read. The process starts again, okay? Now, sorry. The process starts again. Name department, okay? This data will be stored in the input buffer, okay? Now, so 102 B and HR, same 102 B and HR, it will be assigned, okay? So we have already these three variable names present in the PDV, right? Okay, like PDV is nothing but a permanent logical memory area, no? So this whatever data that we have in PDV, it will be sent to the output data set. So we already have this name, ID and department, no? So now it will start reading the values 102. So this 101 will be replaced by 102. Okay. B and HR. Okay. So this data will be sent to the output data set. Okay. Now, so if it has another line, okay, in the card statement. So in order to read the next line, next what it will do, it will go to the input statement. This n is nothing but the number of iterations, which is, in other words, we can say how many times it has read the input statement while program execution. Okay, so how many times it will read, how many data lines that we have here, that many times it will keep reading the input statement, right? So for reading the first statement, like for reading the first line in the card statement, it is reading the input statement once, right? For reading the second line in the card statement, again it is reading the input statement. So by the time when it is reading the second line in the card statement, how many times it has read the input statement? 2 times, right? So n value will be 2. Okay. So if you have like third line, in order to read the third line, again it will be reading the input statement, right? So in order to read the third line, by the time how many times it has read the input statement? 3 times. So n value will be 3. Okay. See, n value will be is 1, n value is 2. So how many times it is reading? N is nothing but the number of iterations. In other words, how many times it is reading the input statement in order to execute this line, or else like before executing that line, how many times it has run the input statement. Okay. Clear?
Yes, Pavani.
Yes, no? Now, the next one is set statement. When it is reading the data using the set statement or in output method, it will not create the input buffer. Okay, we'll have only source data, PDV, and output data set. Okay, source data, PDV, and output data set. No input buffer. Now, so we'll write a program here. Data test. Okay, set from SAS help dot class and run. You remember one thing, like when teaching you the dataset options, I told you that if you write some dataset options in set statement line, it will be more efficient than writing in the data statement line, like keep, drop, rename. Remember? So now I'll
Yes.
tell you like why it is more efficient. Okay. So data test set SAS help dot class. So it will create when it reads the first line in the program data test, it will create a data set called test, and by the time it will be an empty data set, right? Nothing will be there in that data set. Okay. By reading the set statement, it will understand that we are referring to some other data set, some other SAS data set only we are referring to. Okay. Set from SAS help dot class. Okay, SAS help. SAS help is nothing but the library, and class is nothing but the data set that is present in the SAS help library. So by this, what it will understand, we are creating a new data set called test, and into that test we have to, because of the set statement, it will understand we have to copy whatever data that is present in SAS help library class data set, copy all that data into this test data set. Okay, and run. That's what it will do, no? Okay. So, so in source data, what is our source data? SAS help dot class, right? So in this data set, what are the variables that we have? Name, age, sex, height. So height and weight, I'll write like HT and WT. Okay. Name, age, sex, height, and weight. These are the different variables that we have, right? Various variables that we have in the class data set. So all these variables, because of this, what will happen? All these variables will be moved to the PDV, right? And the same data, like variables as in all the data values also, like whatever data that is present in class data set, all the data will be moved to PDV. And from PDV, it will be copied to output data set. Okay. Now, I'll write here keep statement. Okay. I want to keep only name and age. Keep only name and age. Okay. So if you write here, when it executes the first line data test, okay, it will create an empty data set called test. By this time, will it understand what this option is? Keep equals to name and age? No, right? because when it is executing only the first line, then it will not, because it is an empty data set, no variables or no observations, nothing. So it will not understand what this name and age variables are. So it will hold in some of its memory. Okay, keep equals to name and age. That statement it will hold. Next, set. Because of this set statement, it will understand, okay, we have to copy all the data. Okay, so what it will do? So it will copy all the data into, it will move all the data to PDV, right? To test data set. In order to create this test data set, it will move all the data into PDV. Next. So before creating the output data set, then it will understand, right? Because it has already read like what is the data that is present in class data set, SAS help library. So now it will understand like what is this name and age. Okay. So when it is creating the output data set, okay, here it will understand, okay, so not all the data we have to copy only name and age because of this statement. Okay. So it will copy only name and age. In PDV, you will have all the data, but to the output, it will send only name and age. Okay. So if you write the same keep statement in set statement line, it will be more efficient. Why it will be more efficient means, Control C. Okay. So set data test, it is an empty data set. Okay, next statement is set SAS help.class keep equals to name and age. So when it reads the set statement, okay, it will think, okay, it will understand it has to copy the class data into this test data set. Okay, it will copy. But is this the end of the statement? No, right? Still we have like some continuation. What is that? Keep equals to name and age. Now when it is reading this class dataset, automatically it will understand, no, because those are the variables that are present in class dataset. So it will automatically understand, okay, because of the keep option, it will understand, okay, we have to keep only name and age. Okay. So when it is sending the data to PDV only, rather than copying all the data into PDV, it will copy only name and age. Whatever is the required data, it will copy only that data, name and age. And the same will be sent to the output data set. Okay. So which is more efficient? Here what it is doing, it is reading all the data into PDV, and finally when it is creating the output data set, it is realizing that it has to copy only name and age. But if you write the keep statement here, keep, drop or rename, whatever changes that you want to do, if you are writing in the set statement line, then what it is doing, rather than copying all the data into PDV, it is just copying the required data. So obviously the program execution time will be lesser. So reading 5 columns will take more time when compared to reading 2 columns, right? So same logic. Clear?
Yes.
Clear, no?
Yes.
Okay. Okay. So if you want, I'll show you the difference. Okay. Because of lesser number of columns, it might not show you that effect. Okay, because of lesser columns, it might not show you that big difference. But when we are reading, like, suppose if you have, say, like, if you have like 10,000 observations, okay, or if you have like millions of observations or records, in that case, will have like huge impact. Okay. Here, though, you might not have like that effect. Yeah, here it is not showing that effect because like only 19 observations, so it's not such a huge data. So because of that, it is not showing any effect. But when you are reading like larger amounts of data, okay, then you'll have very huge impact. Okay. The next one is output method. Moving on to the output method, this is the other method, right? Output method. Let us create the data set first and I'll explain you later. Okay. Output. We'll change this only to output method. ID. Name. department, so we enter as the SAS statements, right? Observation in this one. Next, character data values we keep in quotations.
Output. We have to write.
Yeah, we'll write output and also length and everything we'll write, okay? Here the name is, we'll say Bob. Bob. Sharon, okay? Let us run this program. So if you run this program, generally what is the data that we get to the output? Only this observation, right?
Right.
Last observation will get to the output because we have seen already like bit process. Now let us take this one because in the output method also we will not have this input buffer, no? Okay. Source data, PDV and output data set. Now, so it is reading as a statements. ID equals to 101. So it will read first ID, okay, and to this it will assign the value 101. Okay. Or else you can say like ID equals to 101. So this is the first statement. After this first statement, it will send the data to PDV. Okay. Now, so because there is no output statement, what it will do? This is the permanent like program data vector. It is the permanent logical memory area, right? So it will store in its memory. ID equals to 101. Name equals to A. Okay. It will do the same for name equals to A also. Okay. Name equals to A. Next one is department equals to IT. For department equals to IT also it will do the same. Because there is no output, there is no command we are putting here to send the data to output data set, right? So it is reading everything as all the variable name and value, it is reading as a SAS statement. So when the SAS statement will be sent to the output data set, if we give some command, if we give like some keyword or command anything, then it will send to the output data set. Until it will store in its memory only, no? So it is storing in its memory. Okay. Now, what is the next statement? ID equals to 102. So now what will happen? This 101 will get replaced by 102. So Bob, okay. So but already for name, how many characters it has read? Only one character, right? So it will prefix the length. So when it reads for the first time, when it reads the statement, it will understand this as the variable name, right? And it will take the length as 1. So it will fix the length as 1, okay. So out of this Bob, it will just take the first one character and it will leave the rest 2 characters. Okay. Next, what is department? HR. It will take only HR. Because when it is reading for the value for department for the first time, what is the length? 2. So it will prefix the length of the department variable as 2. Okay. So it will read only the first 2 characters for the entire program execution. Okay. So now, so are there any further statements to read? No, right? So now it will send all this data to the output data set. It will copy all the data to the output data set to create the observation. If you want to send the data, see, you can write output statement anywhere, like after ID, after name, after department, okay, wherever you want to write output statement, you can write. If you write after ID output, okay, output, then what will happen? It will send only this part to the output data set, right? Okay, it will copy only this to the output data set. So the rest all is nothing. Okay, so it will be an empty. Now, if you write after this, if you write the output data set, okay, so name is A and department is IT, right? So name will be A and IT, sorry, and department is IT. Okay, so now by this time, what is the data that is present in the PDV? If you write this output, so when it is executing this output statement, what all data is present in the output data set? ID, PDV, ID, name and department, right? So it will send all this to the output data set. Okay. Clear? Hello?
Yes,
Yes,
Pavani.
Pavani.
Clear, no? So wherever
Yeah.
we write the output statement, till that point, okay, till it executes this statement, or else like before it executes this statement, whatever data that is present in PDV, it will send all that data to the, it will copy all that data to the output data set. Okay. So here you are writing output. So before it executes this statement, whatever data that is present in the PDV, it will send all that data to the output data set. Okay. So if you want, we can write here proc print, okay? Proc print data equals to test and run, okay? See, for name and department, when it has executed for the first time, like output statement, there is no name and department values that are present in the in PDV, right? So it is giving you only that ID value in the output. Okay? Clear about the output also? Hello?
Yes.
Clear, no? Okay. So this is about the output statement. Okay. So that's the reason generally what we do is, so we want to send this IT name, we want this IT ID name and department together to form one observation, right? So before before this ID name or department variable value get replaced with the next name, ID and department value, what we do is we'll send it to the output dataset by writing the output statement. And how to overcome with the length statement? We know, like, by using the length statement, right? By using length and name. Okay. So for which variables we want to increase the length? I'll increase this to 6 dot, and department I'll increase to 4 or yeah, 6 dot. Okay. See. So this is about the output method. So this is the backend process that will be running. This is like the data step processing. Okay, like it will take two phases. One is compilation phase and the other one is execution phase. And in compilation phase, it will make the program set ready for the execution. Okay, like it will check everything, syntax errors and all the names and everything, keywords. It will check, keep checking, and then it will create like what is the necessary memory according to the data, according to the program that we have written, what is the necessary memories that it has to create, it will create. Okay. And then it will start executing the phase. In execution, it will assign the values to the variables. Okay. Now, and also in compilation phase, what I told you, it will create the descriptor portion of a data set, right? So if you want to know the descriptor portion of a data set, we have methods. One is proc contents. Okay, you have to follow this, you have to make use of this procedure called proc contents. Okay, proc contents data equals to, suppose if you want to know the descriptor portion of the test data set. Okay, so whatever data that is present in work library, for this data set you want to know, then just write here data proc contents data equals to test and run. It will display all the descriptor portion in the log in the output window. See, dataset name work.test, it is stored in work library. What is the member type? What is the engine? Okay, what is the version? When it is created, when it is modified. Okay, so protection as in like, does it have any password or anything? Okay, security code. Label. Okay, observations. How many variables? Observation length. What is the length of the observations? Okay, sorted or not, compressed or not. Okay. What system that you are using, like system, some system configurations. Okay, what is the complete file name, and here it will display the information in three different tables. In coming to the last table, here it will display you the what are the variables that are present in the test data set. Okay, it will display all the variables that are present in the data set. But how it will display means, it will display the by alphabetical order. Okay, it will display by the alphabetical order. See, department ID name, and what is this number means, in dataset, what is the sequence of that variables? Okay. So if you refer to the dataset, department is what name, what column it is? Check in the dataset.
Second.
Yeah, second column, no? So it will give you that number here. Okay. What is the position of that variable? Okay. And you also have one more, like you will not get such clear information, but you also have one more method to know the attributes. Double click on the data set. Okay. So if you want to know the data set attributes, okay, then here you have an empty box, right? Cell. So just double click on that. See, table attributes. Okay. So you'll get like when it is created, when it is modified, what is the type, okay, what is how many columns, how many rows, okay. And if you go to the advanced, you will get like this information. Is it sorted or not? Okay. How many number, like do we have any deleted any rows or not? All that information will be displayed here. Okay. That is table. If you want to know the individual column attributes, if you want to know the column like name attributes, then go to that, click on that, double click on that name. It will display all the information like what is the type, format in format, okay, and what colors. What is the, what should be the foreground color, background color? If you want to change, you can change it. Fonts. Okay. Clear, right? Hello?
Yes, Pavani.
Yes, Pavani.
Yes, cool. The next one is, suppose if you want to know like what are the proc contents, like this prepare portion for the dataset that is present in SAS self library class dataset. Then just write library name first and write the dataset name. Okay. Clear?
Yes.
Hmm. Okay. So this is about today's session.